Hi, I'm Keith Barker, and on behalf of the entire CBT Nuggets family, I'd like to welcome you to the tool sets of Backtrack and Kali Linux. In this introduction, I'm going to share with you a couple of critical things, including how to get the absolute most out of the series and how to keep safe. Let's begin. I am very excited about the idea of you joining me in this Backtrack Kali Linux series. When I talk about Backtrack with individuals, a lot of times people have never even heard of it, which is really surprising to me. Backtrack and its replacement, Kali Linux, have literally hundreds of hacking and penetration testing tools all built in. So you basically install the Backtrack or the Kali and the tools are just ready to go. Now I want to share with you a word of caution with using any type of hacking or penetration testing tools. Let's imagine that there's a young man who's 22 years old and he has his hands on Backtrack or Kali Linux and he takes one of the tools or many of the tools and launches them, and whether he intended to or not, let's say he disrupts the business, steals information, or causes damage to a public network or to a public company or even to his private company. What is going to be the impact, negative impact to that person if he is caught as the perpetrator of that attack? And the answer is never anything good. That's going to be a very, very bad situation. So I want to make sure right off the top that we make sure that we're going to use these tools for white hat use only. Now you might say, well, Keith, exactly what does that mean, white hat use? Does that mean I have to put on a white hat every time we're going to use these tools? And the answer is not a physical white hat, but a logical white hat. A white hat is an individual who is going to use the tools only in an authorized manner, meaning you've got explicit authorization to do exactly the test and the penetration testing tools you're going to be using, or they're on their own private network and never going to touch, bother, damage, or disturb anything outside of their own private network that they are completely in control of. So that would be white hat use. The far extreme of that, which would get you into trouble very likely, is black hat. And that's where you use the tools to do malicious things to networks where you're not authorized. We want to stay completely away from black hat. And gray hat is everything else that's not really clearly defined. So I would encourage you to stick with only white hat use on authorized networks where you are in control or authorized for the specific tools you're going to be using. And if you're not sure if you're authorized or not to run a specific tool, don't run it. If you do anything that is illegal or not authorized, it's completely on you, and I would strongly recommend you completely avoid any of that activity. This series is intended for individuals who at a bare minimum understand network fundamentals. For example, if I said to you, hey, what is an IP subnet? How does DHCP work? What is ARP? What's the difference between IP version 4 and IP version 6? A person should be able to at least understand those concepts before they ever start attempting to use attack or penetration testing tools that are covered in this series. So there's lots of great resources for those fundamentals, like Network Plus and Cisco and HP and Juniper have entry-level courses and training. I would strongly recommend you have a solid understanding of the fundamentals of the network before you start approaching tools that could be used for penetration testing and hacking against those networks and systems. To emphasize it one more time, we'd only want to use any of these tools in an authorized environment only. For example, let's say you and I get hired to go into a company and do penetration testing and vulnerability assessment. And we walk in, we're just not going to open up the entire toolkit and start launching everything. We are going to have requirements and guidelines of what we are allowed to do and not do. So even in those environments where you have specific authorization to do some tools, it doesn't mean you get to do everything. You have to stay within the guidelines that you're explicitly authorized to do. Anytime you or I step outside the lines of what we are authorized to do, we are putting ourselves at risk, which is never a good idea. So stay safe. At the end of the day, the major benefit of using these tools in a positive, authorized way is to improve the overall security posture for a network. For example, let's say we have a company, they have a network, it's in place, they've put in the correct controls, the technical controls, access list, authorization, authentication, all that stuff, and they think it's set. Then they hire a third-party company to come in. They have that third-party company run a certain set of penetration testing tools within guidelines just to verify that the defense mechanisms that they currently have in place are enough. And if they're not, they get the results from the penetration testing and they can make changes to improve their security. Again, with the goal of making sure we have the best fortress of security possible for that network. To get the absolute most out of this series, I would strongly recommend to stay out of trouble and to have the opportunity to practice these commands. Build an isolated, meaning not connected to the rest of the network. Build a test network where you can go ahead and practice. And it can be a physical network completely separate, or you can do it virtualized. You can have a virtual network living inside your host computer, again, keeping it separate from the outside world so that none of your attacks will accidentally leak out to any production networks. Once we have that test network in place, the secret to becoming good with these tools is to practice in that isolated area, that test network that we've created. Now, here's something that I've discovered many, many years ago. If I'm reading a book or watching a video and I try out a command myself, a lot of times I might have a typo, I might miss a switch, an option in the command line, and so the command doesn't work. Very, very frustrating. So here's what I've done. For many of the videos, I've overlaid the actual commands I'm using in bigger fonts. So if you're on a smaller viewing device, you can actually see the commands. And check this out. I've also included for many of the videos Nugget Lab files. And these Nugget Lab files are the commands that I'm actually issuing. So if you wanted to, in your sandbox test environment, practice those same exact commands, you could download from the Nugget Lab download area those files. And that way you could verify the actual commands by looking at the file. Or if you wanted to copy paste, you could do that as well. And this last bullet, just as a reminder, please only use these tools in an authorized way. And if you're not sure if you're authorized to use a tool, or you're not sure what damage it will cause, the answer is don't run it. Stay on the correct side of the line, keep yourself out of trouble, and only use any of these tools in an authorized manner. With these safety guidelines in place, I am so looking forward to enjoying this time with you in the series. We're going to have a blast. I hope this has been informative for you, and I'd like to thank you for viewing. What exactly is Backtrack? Well, if that's your question, you've come to the right place. Let's begin. Our objective for you and I in this nugget is simple, is to identify what exactly is Backtrack. Now, to do that, let's imagine that you and I work at a company, we've been there for several years, and the manager comes up to us and says, "Are we protected?" Now, hopefully, our answer to him or her would be absolutely yes. And we could explain that part of the process of making sure that our network is solid and protected is to, first of all, identify vulnerabilities and weaknesses that are present in most networks. Now, not just our network, but most networks. Secondly, once we identify what those weaknesses and vulnerabilities are and what the risk is if we leave those unprotected, what countermeasures can we put in place? Things like intrusion prevention systems and firewalls and other techniques to help mitigate or lessen the effectiveness of an attack. And then third, once we have those countermeasures in place, we definitely want to validate that those countermeasures are working. And to do that, we want to go ahead and use, with authorization in writing from the people who own the network, we want to use some penetration testing tools to discover and verify that our mitigation techniques are working. See, the reality is this. If we have an unprotected network, we're very likely going to be compromised. If we have a really protected network, but we don't test it, it's also very likely that we could be compromised. So our objective is, where do we go to get a whole bunch of tools that can assist us in testing and using a lot of the same tools an attacker would use? And one of the answers to the question, where do we get all the tools to do the testing, is a distribution of Linux, and they call it Backtrack. What Backtrack is, it's a flavor of Linux that's running. You can either run it several different ways. You can actually run it off of a CD. They call it Live CD. It's really a DVD because it's more than 3 gigs. With Live CD, you simply burn the image to a DVD. You put it inside of a computer. You boot up the computer. You hit the right key so it boots off of the DVD drive as opposed to the hard drive. And then poof, you've got this Backtrack Linux distribution that has hundreds, literally hundreds of tools built inside of it. You can also do that same technique off of a USB. So the key is here that if you walked into an office and you had a USB drive and you plugged it in, if you're authorized to do so, if you plugged it in, you could boot that machine off of that USB drive and have your attack machine right there. And so all a person, an attacker, might have to do is walk in with either a CD or a USB and find a machine that's physically available, plug it in, and without any safeguards in place, they could run Backtrack on that computer in that office. Another option is to install Backtrack, the distribution, to the hard disk. So you can either take the entire hard disk or you can partition the hard disk. Now you don't have to worry about having a specific CD or a specific USB drive to go ahead and boot from. You can simply boot from the actual hard drive on your own laptop. And it's really a penetration testing tool, a digital forensics tool kit, and that toolkit contains a boatload, hundreds, literally hundreds of tools that we can use for all of these purposes. And in our CBT Nugget series together on Backtrack, we'll be covering a lot of these tools. In this nugget, we've identified that Backtrack is a Linux distribution that has tons of attack and penetration testing tools built into it. It can be installed directly on the hard drive, or we can run it from the DVD directly or from a flash drive. I'd also like to point out that we would never ever want to use any type of tool against any network that we aren't explicitly authorized to do that penetration testing or reconnaissance work against. I'm glad you've joined me. I hope this information has been informative for you, and I'd like to thank you for viewing. Installing Backtrack on a virtual machine. Now, the great news is that whether you're doing virtualized hardware or real hardware, the actual steps for installing Backtrack are exactly the same. Let's begin. Our objective for you and I in this nugget is really simple. We want to get Backtrack installed, and in this nugget, we're going to take a look at installing it on a hard disk. And the overview is we're going to download the image. We're going to go ahead and make a bootable DVD boot from that on our computer. Type in Start X, click on the icon that says install. That'll go through a whole process. It'll take quite a while. Reboots. We'd log in as root, and then we go ahead and type in Start X, and that brings up our GUI again. That's it. That's the entire process for getting Backtrack installed on a hard disk, up and running on a dedicated computer. However, for many of us, if you want to practice with Backtrack, maybe you don't have a dedicated computer or you don't want to partition the hard disk, what else can you do? Well, besides using the live CD option, we could also use a virtualized PC for it. So on my host computer that we're looking at right now, it's Windows 7. I'm going to use VirtualBox, which is free, create a virtual PC, and then we'll do the Backtrack install on that virtual PC. That way we have the best of both worlds. So in your case, if you don't want to use VirtualBox, you don't have to. If you have a dedicated computer, you can just follow the steps after we get VirtualBox set up, and they'll be virtually identical. It's been scientifically proven that it's pretty tough to install software unless you have access to that software. So we're going to make a road trip up to backtrack-linux.org to start the download process. I usually use the 32-bit flavor KDE of the latest version. However, if you have a 64-bit machine or you want to create virtual machines that are 64-bit, you can use that one as well. Or if you love GNOME instead of KDE, that's great. But for these demos, I'm going to be using the KDE flavor 32-bit in case you want to mirror that as you practice along. That download of 3+ gig in size will take quite a while. It'll download as a .iso, and then from that ISO, you could mount that inside of a virtual machine, or you could burn it to a bootable DVD if you're going to use it on another machine. To get VirtualBox, which is also free, we go to www.virtualbox.org and download the software from there. Now, once VirtualBox is installed, there's basically a walkthrough that says yes, 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 yes. You install everything. Once that's installed, you can then use VirtualBox to emulate the hardware where we're going to install the Backtrack. In this demonstration, that's exactly what we're going to do. Once VirtualBox is installed and running, this is a copy of VirtualBox I've had for quite a while. If we go to Help and we go to About, this is the version I'm running, 4.2.6, which I've been running for quite a while. In any event, that's the version. If you want to mirror that exactly, that's perfectly fine. Let's create a brand new virtual machine. And I'm going to call this BT CBT Nuggets. And this is the one I'm going to use inside of this virtual machine throughout our series. And I'm going to specify that it is a Linux flavor, and I'm going to say it's going to be based on other Linux. Specifying the type and version right here isn't going to guarantee it's going to be perfect for you. What it is just some recommendations that in the background VirtualBox is going to use as default settings. We're going to specify everything we want manually, so it doesn't matter too much what you specify here. But if you want to mirror this environment, this is what I'm setting it for. So we'll click on Next. It says, how much memory do you want to give this guy? I'm going to give him 4 gigs. 4096. Now, if you don't have a machine that has 4 gigs to spare, don't worry about it. If you give him 2 gigs, will everything work? Very likely. If you give it 1 gig, will everything work? Very likely as well. So I'm just going to give it 4 gigs because I got plenty of memory on this machine to divvy out, and I'm going to click on Next. And it says, okay, what about the hard drive for this guy? Do you want to create one or use an existing one? I'm going to create a new virtual hard drive for this virtual machine. So I'm going to click on Create, which is the default. I'm going to say, great, just a VirtualBox disk image. I don't need to go back and forth with other emulators. I'm going to click on Next, and then I'm going to say, and it's asking me if I want to allocate all the size up front or do I want to have it dynamically grow. I'm going to say go ahead and do it dynamically up to the fixed size. Click on Next, and I'm going to give this guy 20 gigs, approximately 20 gigs. Now, before you do this, you might want to just take a look and see how much hard disk space you have. Inside of VirtualBox, you can specify where you want virtual disks to be kept. I keep mine on an external 2 terabyte drive, so I never have to worry. Well, not true. I don't ever have to not worry about it, but I've got plenty of disk space on that external 2 terabyte drive, so I'm going to give it 20 gigs for this virtual hard drive for this new computer. And 20 gigs should be more than enough for Backtrack and everything else that's going on. So I'll click on Create. And now we're not done yet. So now I've got this BT CBT Nuggets. I'm going to go ahead and click on Settings. You can click on Settings here, right-click on Settings. And let's go through these items together. So in general, I think we're okay there. Under System, so I'm going to remove floppy just because I don't have a floppy drive in this virtual machine. And I wanted to tell it that the boot order should check for any media in the DVD player first, because that's where our Backtrack distribution is going to be sitting for the initial install. And that looks great. So I've got my base memory of 4 gigs up here. That looks fine. If we go to display, I'm going to kick him up to 128 megabytes of RAM that he can go ahead and use. And I'm also going to enable 3D acceleration in case I want to get tricky with some graphics. Again, you don't have to use these settings, but I'm just saying if you do, if you want to mirror this Nugget series, this is the settings that I'm using. Under storage, here we have this empty CD-ROM drive. Now check this out. I've downloaded the actual image for Backtrack, and I have it sitting on my hard disk. I'm going to go ahead and tell my virtual machine that this CD-ROM drive is not empty. I actually want to point to, literally, an image file. So I'm going to say choose virtual CD disk image file. So here's my Backtrack image, the 32-bit one I want to use. So I'll double-click that to select it and check it out. Now that drive represents that ISO image. So it believes that CD-ROM is mounted. I am not going to click the live CD/DVD. If I did that, then even if I tried to eject it, it wouldn't eject it. So I may need to eject that. I'm going to go ahead and leave that off, which is the default. Let's go down to network. This is important. Now what's going to happen is I'm going to use my built-in Windows 7 network adapter as a bridge for the main Ethernet interface on my Backtrack device so it can get out. So I'm going to say for network adapter 1 for this virtual machine that's coming up, I'm going to go ahead and bridge it, and I'm going to bridge it across to this guy right here. I have a little Linksys AE1000 USB wireless adapter that I use on the Windows 7 host to connect to the rest of the network. So I'm going to have it share that. So that means that this Backtrack machine will now have the access on the same interface that my host machine has. And I also want to go down to advanced, and I'm going to put in a different MAC address. I'm using CC1E6783. And that way, as I see that MAC address floating around, I'll know exactly whose MAC address that is. It'll be the MAC address of the LAN-based interface on this virtual machine called Backtrack. So that's great. I'm going to go ahead and allow. I'm also going to specify allow all for promiscuous mode in the event that we need to do anything with that interface. Now, what I'm doing here is a little bit tricky and a little bit clever. I'm going to go ahead. I'm going to say I want to enable USB 2.0 controller, and I want to add a device. Now what I'm doing is give me a pick list right here of all the USB devices that I could allocate to this virtual machine. I'm going to go down here. I'm going to grab this Realtek wireless adapter. Now this is the second wireless adapter card I have plugged into the host computer, the Windows 7. It happens to be an Alpha USB wireless adapter. I'm going to allocate this adapter directly through the USB connection to this virtual machine. So what that means is I've got a wired connection virtually bridged through the host machine's interface. I've also got access to this wireless interface that my Backtrack, my virtual machine, will be able to use completely. So if you're not doing virtualization and you've got the Alpha USB adapter, you simply plug it into your computer and Backtrack can have access to it. But here, I've got to allocate that USB resource directly under the control of this virtual machine. So now that that's done, I will click OK. And to start this off, I can either double click it or I can highlight and click on Start, either way, and it's going to boot up. So when this boots up, now what we're doing, let me move this out of the way so we can all see. So as it boots up, we're going to go ahead and boot to that DVD image that we downloaded that has the Backtrack on it. And right here, this is exactly as it would be on a physical machine. We have to press enter, and that's basically going to boot from that DVD image. And then in 27, 26 seconds by default, it's going to boot into text mode. That's great. I'm going to press enter one more time. And this is loading up the DVD, the operating system Backtrack, and all of its bells and whistles loading from the DVD. Now, if I'm on a physical PC and I've put the DVD in, I'm booting up, you might have to hit an escape sequence or change the BIOS so it will actually boot from the DVD instead of trying the hard disk first. So I scroll this up so we can see the activity a little bit better. So to this point, we've downloaded the Backtrack image. We booted from it. Now here I did it virtually through the virtual machine. And an external machine, you use that from an actual DVD you plugged in. And here's where we're going to type in start X. And that starts the graphical environment for Linux. So we'll do a start X. And we'll type that incorrectly. Start X. I said start, and it didn't. I said, Keith, you probably typed in star. It needs to be start. So I did start X, and now it's asking me if I want to install it. This icon right here. Do you want to install Backtrack to the hard disk? Now, I could just use Backtrack right here. I could be just ready to go. But I want to install it to the hard disk, so I'm going to click on Install Backtrack. Once I double-click on that, it's going to ask me a few questions. What language? I'm going to say English would be great. And setting up the clock. It'll ask me about the keyboard, where I'm located. I happen to be in the Pacific time zone. It really is 12:34. I'll click on forward. And then it asks me about my keyboard layout. I'll accept that. So it says currently I've got no other operating system on this 22 virtual gigabyte hard drive inside of VirtualBox. So I'm going to say go ahead, erase it, and take the whole disk for Backtrack. So I'll click on forward. It's going to do exactly that. It gives me a little confirmation message, and it's off to the races. So we will let it do its magic. I will pause the recording, and I'll come back near the tail end of its automated install that it's in the middle of doing. So now it's all done with the install. It says, okay, you can keep on working with this DVD-based version that's already running, or you can click on Restart Now. We'll boot from the hard drive, and we'll take it from there. I'm going to click on Restart Now. And that's going to cause it to go ahead and shut down, and it should reboot back up from the virtual hard drive this time instead of from the DVD. I've noticed that at this point in a virtual machine, at least on my machine here, I had to press enter to actually trigger it to go ahead and do the actual reboot. So now it's doing the reboot, and it should boot up, and it should come up from the hard drive this time as opposed to booting up from the actual DVD. So I want to scroll this up just a little bit so you can see it with me. So to this point, we downloaded the software. We actually booted off of it. We ran StartX to get the graphical user interface. We ran the install by double-clicking on the icon. Once it installed, we rebooted it, and now it's asking us to log in once again. This is an important one to be aware of. If we want to log on, we're going to log on as root, and the password is root spelled backwards. So it's T-O-O-R. And that brings us to this point right here. We've just logged on. If we want the graphical user interface once again, we're going to need to type in Start X. That will start that X Windows type GUI for us. So we'll type in Start X, and that'll launch the graphical user interface. And my friends, we've just installed Backtrack in a virtual environment. Now the great news is the process of doing this on a physical machine is exactly the same, except we don't have to worry about the virtualization with VirtualBox. We'll just do the same exact process with the actual DVD on the physical machine. One last thing, because we no longer need this icon to install it because it's already installed, we can right-click and simply say, I want to go ahead and move that to the trash, and that won't be sitting on our desktop anymore as an icon. In this nugget, we've taken a look at how simple it is to download and install Backtrack, either in a virtual environment using the help of VirtualBox or doing it on a physical piece of equipment. I've also included in the Nugget Lab download area the exact settings and versions that I'm using for Backtrack and for VirtualBox in the event that you want to replicate those exactly as you practice along with me. I hope this information has been informative for you, and I'd like to thank you for viewing. Connecting Backtrack to a network. Some changes have been made over the last few revisions of Backtrack, including the default behavior for networking. It's important to be aware of, and it's also important to be able to configure the IP address that we want to use on an interface. We're going to cover all that in this nugget. Let's begin. So let's imagine that you and I have gotten the go-ahead from our management to start doing some penetration testing. And so we've downloaded Backtrack, we installed it, we looked at that in the previous video, and we're ready to go. Now, one of the key elements of getting this to work is we need to have some connectivity to the network. And it could be wireless or it could be wired. And here's what I'd recommend. A lot of times people use laptops because they're fairly portable for using with Backtrack. So here's what we're going to do. We're going to have a local area network connection that's wired. I would recommend you do the same. And then we'll use the wireless for additional investigation and some attacks that we're going to be doing together in this series. But that's how I have mine wired. I've got a laptop, a physical standalone laptop, and I've also got my virtual machine, and they're both pretty much configured the same way. I've got a logical wired connection on my virtual machine through VirtualBox, and I also have the Alpha card that we mentioned in our previous nugget that has direct access by this virtual machine. So it's as if the Alpha wireless USB card belongs to this machine, and my virtual machine also believes it has a wired connection off to the network. So let's say we have our physical cable over to the switch, and now we're physically connected. Here's a big change with Backtrack in its current versions. Backtrack used to have networking disabled by default. You had to actually go to the command line and enable networking for it to work. Well, current versions of Backtrack, including the ones we're using in this Nugget series, they have networking enabled by default. That means if we plug into a switch, we're automatically going to start asking for DHCP services. So if that's not your intent, you may want to hold that thought, not connect to the network, configure your IP address settings that we're going to take a look at right here, and then once you're perfectly set the way you want to be, then go ahead and connect the cable. That way you're not tipping your hat as far as letting any devices know, hey, there's a new MAC address, he's asking for an IP address, if that's not what you want to do. So DHCP or static, we can be wired or wireless. Again, I'd strongly recommend we use our wired connection for our base connectivity for the system, and then we can start doing our penetration testing and other tests with our wireless interface. So with the current flavor of Backtrack, if you just want to use DHCP, you don't need to enable it. It's on by default. If you want to go ahead and disable some service or an interface, you'd want to do that manually before you connect. What I also like to do is also enable SSH. Now, why is that? So let's say I have this laptop, or we have this laptop, and we park it somewhere in our network, and we don't want to have to sit at the actual console to do a lot of our command line work. If we enable SSH on this guy and he's parked in like a wiring closet or some other convenient place, we can then go ahead and use SSH from wherever we are to connect to that device and run our command line utilities, which is very, very convenient not to physically have to be at that box to manage it. So we'll take a look at configuring the IP details, including how to configure a static IP address and how to make those details persistent. If you want the IP address to be the same every time after you reboot, I'm going to walk you through that as well. So here's our Backtrack system. We installed this in the previous nugget of installing Backtrack. And my question for you is, do you recall, can you tell me how exactly do we log on to this? It's booted up, it's staring at us, asking us to log on. As I recall, the actual user account is root. Do you remember what the password is for root? Now, if you're saying, Keith, it's root backwards, T-O-O-R, you're absolutely right on the money. So I'm going to type that in. And now we are connected. Also, I just want to confirm, because we did the install previously, I just want to verify that we're on the right system. So here it's showing us that I've got 56.2% of 19.55 gig. That's really close to what we gave it inside of VirtualBox in this virtual machine. So that's a handy little indicator that just gives a confirmation that we are booting from the actual hard disk and not actually booting from a CD still. We also have this IP address, and this is because I haven't changed anything yet. Ethernet 0 is connected to a network where there's a DHCP server. So by default, this flavor of Backtrack, when it booted up, it said, hey, I want to do a discover for a DHCP server. There was an offer. There was a request by this Backtrack saying, yeah, I'll take that address. And then there was an acknowledgement from the DHCP server. So this is the IP address we have. Now, if we wanted to just use that, it's good to go. We should have also learned things like our default gateway and DNS lookup information, and we're ready to go. One way of verifying what our IP address is, let's say we didn't have this boot screen sitting here at the moment. We want to just verify our details. We can do an ifconfig, and that works great. So with an ifconfig, we have this Ethernet 0, which is my LAN interface. It says it's up. There's the key right there. It also has that IP address again, 192.168.1.45, and there's the MAC address. And we hard-coded that MAC address back in the virtual machine. And that's why it believes that's the MAC address, is because that's the MAC address we told it to use inside of VirtualBox. I've also got a loopback interface, and I have a wireless LAN interface. Fantastic. Here's the MAC address for that. Now this represents the alpha card that we mentioned in the install video. So that's great news. It means that this Backtrack system sees itself with a local area network wired connection. It also sees itself with the wireless interface as well that we provided through VirtualBox, direct access to that USB wireless device. Another command we can issue is iwconfig, and that'll show us our wireless information. That's really handy as well. So what this is saying is, okay, we've got one interface that supports wireless. It's wireless LAN interface 0. We have a transmit power of this amount. So I think in the US it's like 27 dBm is the max. Other countries, it's different based on whatever the rules are for the airwaves in that part of the world. So this is not currently at max power. We'll take a look at managing that a little bit later in a different nugget. And I'm currently not associated with any access point. Now, if you're in an older version of Backtrack where networking had not been started and you need to manually start the process, you can do so with this command. /etc/initd/networking space start. And it's already running on this system, so I'm not going to run it. But if you are working on an older version of Backtrack where networking hasn't been started, this is a great way to do it. You can also, on a current flavor of Backtrack, you can also use the command start space networking. And that will effectively do the same thing to start the networking services. Another thing I'd like to do right now is let's go ahead and set up support for SSH. Now to do that, we're going to need some public and private keys generated that SSH uses. To generate those keys, it's a piece of cake. The command is sshd-generate. And it's going to go through, it's going to generate the public and private key pairs that it needs. Now that the keys are generated, the next challenge is how do we train Backtrack to go ahead and listen and be open to receiving SSH connections? And the answer is we have to tell it to go ahead and start that service. And there's a couple of ways of doing that. The shortcut is typing in start SSH, and that will do it. And another way would be to use this command, and that would also start it. So the first one's a little script that automates that process. The traditional way is the way right there that we could use. Now, because it's already running, I don't need to start it again. I just want to give you both options. Maybe you're on an older version of Backtrack. I want to make sure you have every single option at your fingertips. Another really fun feature is the clear command. So if you want to clear off the screen, just type in CLEAR, press enter, and that just clears the screen. Doesn't technically do anything as far as making it faster or anything else, but if you want to have a nice fresh page to work from, clear is the command for you. So let's say that you and I decide that we don't want to be DHCP clients. We want to statically assign an address. We'd want to plan on what that address is, and then we'd use an ifconfig command, specify the interface, the address, the mask, and then the state of that interface. In this case, we're going to say up. Now, if it was already up, we don't need to put the up on there again, but it's a great reminder that if your interface is down and you want to bring it up and assign an IP address, here's how you could do it with one line. If we wanted to verify the details of that command, which is a great idea, anytime you do a command, verify that it actually took, we can use ifconfig and press enter, or tag on the Ethernet 0 to just see that singular output of that interface. And here we have the information that says, yep, it took 192.168.1.222. Now that's fantastic for right now. So what's our next problem? Well, we had a default gateway because we were a DHCP client. Now we're statically configured. We'd also want to configure a default route. So we're going to go ahead and do a route add default gateway of 192.168.1.1. Now, is that the perfect default gateway to use? The answer is it is, if that literally is the default gateway. On this network that this guy's on, that happens to be the default router, the default gateway. So I'm going to tell this Backtrack machine to go ahead and use it to reach any non-local networks. So how would we test something like that? Well, we can certainly try to ping the default gateway just to make sure it's up, or ping an internet resource. Let's go ahead and do that. If that works, we know that there are default routes working, our IP address is working, and everything else. Let's go ahead and ping 8.8.8.8. That's a DNS server from Google. Fantastic. And we'll do a Control-C to stop that. I want to point out that as we get into our nuggets with specific penetration testing and attacks that we're going to do, we want to be very careful not to be connected to the live internet. Why is that? because I've seen this happen more than once. Maybe we're practicing with some type of a SYN flood attack, and we're spoofing source addresses, and we're throwing hundreds of thousands of SYN requests at some poor device inside our private network. But because we were randomized these source addresses, the replies are going back out to the internet from the victim as he tries to acknowledge and respond to the three-way handshake. So in this case, we're not doing any attacks at the moment, so it's not a big deal. But I would like you to pay special attention to the fact that anytime you're doing any type of testing, you don't want to be connected to live networks where you could cause harm or be singled out as somebody trying to cause harm. So let's see, we've configured a static IP address, the default gateway. What about DNS? Now, because we were a DHCP client, it's very likely that we had learned DNS server information from our DHCP server. And that information may still be hanging around in our memory banks. We can verify that by using this command. We can do a more or a cat, either way, and look at the contents of etc/resolve.conf. And that's showing us that that name server that we currently have is 192.168.1.1. Now, I did not put that there. This is a brand new system. We booted up via DHCP. So let's say that's not the name server, the DNS server we want to use. How would we change that? Well, one simple way of changing that file would be to type in echo name server, the IP address of the name server you want to use, and then send that over to that file with the greater than symbol. And that should change that for us. We do a couple up arrows and press enter, and now it's changed. So now our DNS server is 8.8.8.8. And to test that, we can do a ping, for example, of google.com or something else. And if that works, which it looks like it is, that implies that, first of all, name resolution is working, and also internet connectivity is working as well. I'm going to do a Control-C to stop that ping. Our next challenge is this. If we rebooted right now, the IP address that we configured, the 222 address for our host, that would not be remembered anymore. How can we save this, make it persistent across reboots? Well, there's actually a couple ways of doing that. What I'd like to share with you is how you can edit the actual interfaces file that actually controls the information of what IP address, when this thing boots up, is going to be assigned to an interface. Now, to edit that file, we can use VI, and there's also some graphical editors we could use as well, but since we're here at the command line and we haven't kicked off the graphical user interface yet, let's go ahead and use VI, the visual editor, and we're going to edit the file called interfaces, which is in the folder of Etsy and the subfolder of network, and we'll simply press enter. Now, at this point, if you haven't used VI in a while, Google might be your friend and help you give you some commands, but it's actually pretty simple. It's a basic editor. Now, some people love VI. I remember learning VI back in the 80s, and I've never been a huge fan of VI. However, it is simple, and it is on most operating systems of Linux, so we can go ahead and use it. So here's how we're going to start. We're going to hit the insert